I'm going to need to move over. We're still about 2 minutes out. Yeah, I don't expect anybody to read anything before we get started or before the class starts. That's a dumb requirement. If the class hasn't started, why should you read before the class starts? Just saying. It's weird. I'm going to get some more water and then we'll get started. Okay. 5:31. Let's get started. Welcome to CIS 195. This will be, this class covers Windows, but due to the changes that Microsoft has done, this will cover Azure instead. My name is Irvin Lembus. I will be your professor for this for the next 16 weeks. I am watching the Discord chat, the YouTube chat, and Zoom. So if you have any questions, ask away in any of those places, and I will answer. Like I said, this class will help you understand how the Azure cloud system works through a lot of hands-on learning. There are a number of links that you need to be aware of. For Cabrillo College students, that is the link that you should be using to access the class. If you are not a Cabrillo College student, then you'll use that link instead. These links are available on my site, infosecirvin.info/class. If you are part of this course, you need to be on Discord. Discord is actually a very big part of the course. There is a bot that is watching the traffic that's happening on the channels, specifically it's StatBot. So the way that this works is it will tally up the number of messages you send and the conversations you have. And at the end of the course, I will take that and add points to your grade. So this means you definitely need to be talkative and collaborate with each other, because if you talk very minimally, you're going to get a low grade. And from last semester, when I implemented this, people who did not speak a lot often actually saw their grade go down by a whole letter grade. So letting you know now that Discord does play a big part in this course, and you should use it liberally because you don't want it to affect your grade later on. All the recordings will be posted on YouTube. And that is a really long and ugly link, but that is what I have for now. So that is where all these lectures will be stored in a playlist in order, so that if you miss a session, it's perfectly fine. I don't take attendance. I don't make attendance mandatory. As long as you are submitting your assignments on time and you are talking on Discord, I see that you're around, you'll be fine. And of course, you'll need to use this link to get your Azure credit. You will need to verify that you are a student, specifically Cabrillo College students. So what you'll need to do is to go on the Cabrillo website and reset your password to your Cabrillo account. Then you'll be able to log in as a student into Gmail, and you'll have a student.cabrillo.edu account that you can then use to sign up to receive the free credit from Azure. You should not be paying for any cloud service. You should be able to complete the entire course within the free credits that they provide. And if you get stuck at any point, you just feel free to ask away. The class is structured in a very easy format. I'm using module 2 as an example because it could fit better on the slide. But the first 3 modules are the same. The 4th one I'll talk about in a moment. First off, every module has a certification tied to it. My rule from all my classes stands that if you get and pass that certification, you will get an A for that section. In this case, we're covering 4 different certs. So if you are able to get those 4 certs, you get a perfect A. Don't have to submit anything else. But you'll see what cert we're going to cover at the top of each module. Next are these part submissions. As you'll see, the content that we're going to go through has a lot of little breaks and a lot of little labs. As you complete them, you will submit proof of completion into those specific spots. This is what the first submission looks like, where you need to display your name, the email you used to log in, and the XP that you gained, and any badges that you gained. You submit that into the part submission, and you'll get full credit for completing it. Now, I'm going to go at a certain pace. That does not mean you have to go at that pace. If you feel like I'm going too slow, you are more than welcome to go ahead. There is no penalty for finishing early. There's only reward. Because all you have to do is complete all the parts and complete your skill submissions for each of the modules, and you're done. There is no final. exam. Your final exams will be the skill submissions. Your skill submissions will look like this. Using your credit, you'll build a unique infrastructure of your choice based on the content that you learned. So I'm giving you the freedom to create infrastructure based on the stuff that you're learning. You'll schedule a meeting with me where you'll go over what you're gonna make. You'll receive the okay from me, and then you'll make a video showcasing that which we discussed. That will be submitted for final credit, and that will mark your final for that module. So you'll have 4 of these to do in the semester, each due every 4 weeks. Now for my Cabrillo College students, I want to make clear the due dates. On Canvas, you will see 4 main dates for each of the weeks. For example, the AZ 900 Part 1 is due on February 20th. If and when life happens and you are unable to turn stuff in at the due date, there is no penalty in any of my courses. As long as you turn in your assignment before the due until date, you are fine. So if and when life happens and you are unable to submit one of the parts or your skills submission in time, don't worry about it. As long as it's before May 18, 11:59, you can submit your work for full credit, because I understand life happens and there is no need to punish you because life happened. This is true for all assignments with exception of the census assignment, which is really just a little assignment that lets me know you are still involved and still active in the class. Because I have to do census for every class every semester. It just so happens that this semester the day is February 8th. So if I don't see any activity from you by February 8th, I will have to drop you. So please make sure that you are active so that I do not drop you from the course. But once again, you are, if life happens and when life happens, don't panic about this course. Just make sure that you resolve that issue and you complete this course before May 18, 11:59 p.m. Are there any questions? Cabrillo College students can go to the Cabrillo College website to reset your password. The username would be your ID. Once your password is reset, then you can log on to Gmail and you'll get a student.cabrillo.edu email. And that's what you'll use to get your credits from Azure. I know the website got a big change. The Cabrillo College website got a big change. So as soon as I find those links for you to reset your password, I will put those in the chat. But yes, it'll be that student ID at student.cabrillo.edu. And you'll need that in order to get your credit from Microsoft. So let me make a quick video of that. That way it's separate from the content. And then I'll upload that to YouTube. We'll be on our way with Module 1. Yep, It definitely works. And again, you'll need that to request your free credit from Azure. Make a new playlist. Say not meant for kids. Next, next, make it public. Oh, I see a question that I missed. Should we expect this class to usually end at 9:30 p.m.? No. I do not plan on holding you hostage until that time. These classes tend to run about an hour to an hour and a half-ish. So no, I don't expect us to be here for that long, till 9:30. Okay, so that video is done. Stop recording. Or to this computer. Okay, there we go. Part 1. You are more than welcome to follow along using the Azure fundamentals. I have all those links already queued up for you. I'm using them as my lecture notes, so feel free to follow along and ask away whenever you have any questions. So Azure is one of many cloud systems that exist. The big ones would, besides Azure, are AWS and GCP. This class being Microsoft focused, will focus on Azure only. This entry model will kind of look at what Azure can do and its abilities. There are tons of little videos for you to watch as well that help further understand and that you can watch on your time. Azure Fundamentals will be a 6 learning path segment that'll cover the services and features that are provided. This section will specifically focus on the AZ900 exam. It is your Azure Fundamentals exam. It has 6 domains of describing cloud concepts, core Azure services, the core solutions and management tools, the security and network security features, identity, governance, privacy, compliance, and cost management and service level agreements. If you are looking to take the test, you will see the various ways for those sections. And this training, again, the materials that we're going to cover is to help you understand how to use their platform. It has labs that you'll need to complete, and those will help you in building the XP points and getting those badges along the way. All the links are on Canvas. So cloud computing is nothing more than running computations on someone else's computer. In this case, we're going to be doing everything on Microsoft's cloud infrastructure. It's typically cheaper because you don't have to pay for operating costs. Your infrastructure will run more efficiently since it's managed by someone else, and you can scale it as you need without having to buy more equipment. It's an easy way to do work from someone else's data center. The two big trends that are posted are teams delivering new features to their users at record speeds, and users expecting an increasingly rich and immersive experience with their devices and their software. Not having to worry about the local computational power, having the ability to do things like speech recognition and other cognitive services from equipment that you don't have to monitor, and that all that system providing you with all the analytics you need and other telemetry makes life easier for everybody. So again, some advantages of going to the cloud would be the reliability, would be scalability, whether it's vertical, like adding more RAM or CPUs, or horizontal, adding more capacity by adding instances of a resource, like more virtual machines. The elasticity, in order to reconfigure resources as needed. The agility to deploy and quickly configure applications. Geo distribution, being able to deploy applications and data around the globe. And disaster recovery, because the cloud already has built-in backups and data replication and geo distribution. You are able to deploy your applications and data with confidence around the world and be fine should and when a disaster occurs. There are a couple of cloud computing models. The three that are talked about are the IaaS, the PaaS, and SaaS. The SaaS, PaaS, and IaaS? Sure. The infrastructure as a service, this one, is the closest to managing physical servers. That one gives you the power to control the actual physical infrastructure to do what you want. PaaS gives you a managed hosting environment. It's a platform as a service. The cloud provider will give you virtual machines and networking resource, but they'll handle all the physical needs and requirements. Software as a service takes both the prior to and manages them for you. For example, Office 365, you can completely access and use on the cloud through a browser. You don't need to install anything in order to use it, other than the browser, but taking that aside, you don't need to install Excel in order to use it in your browser. You don't need to manage the resources that are behind that program to handle all its computations and whatever work you want assigned to it. It's all managed and you don't see a thing. That's software as a service. The level of responsibility changes depending on which way you go. For example, in the old school on-premises or on-prem, you would be in charge of everything, from the networking, the storage, the servers, all the way up to the applications. When you go infrastructure as a service, the provider, in this case, Microsoft, will be in charge of setting up the networking, the storage, the servers, and virtualization for you. You'll be in charge of everything else. When you go platform as a service, Microsoft will handle more of the work. And then software as a service, they manage everything. You just run your program. And that's it. There is also this option of serverless computing, where it takes away the need to manage infrastructure, where a cloud service provider automatically will provision, scale, and manage the infrastructure needed to run the code. These are very useful in high scalable, event-driven situations when you need something as per a specific trigger. As a refresh, there are different kinds of clouds. There's the public cloud. These are services offered over the public internet and available to anyone who purchases them. Cloud resources like servers and storage are owned and operated by a third-party provider and thus delivered over the internet. We have the private cloud, where computing resources are used exclusively by users from one business or organization. A private cloud can be physically located at your organization's on-site data center or hosted at a third-party provider. There's also the hybrid cloud, providing a mix of the public and private with connections between the two. So again, Azure is Microsoft's cloud service, just like Google's Google Cloud Platform or Amazon's AWS or DigitalOcean or all the others. This is Microsoft's answer to it all. The benefits that they outline, so that provides you with the means to do what you want. They're putting their weight behind this cloud platform. For example, they are future ready. You have choices to build as you need. You can do hybrid, where, for example, you can build a Active Directory domain and have it connected with Azure. And you can get security from the ground up, as long as you have the right support and SLA, you can work with them to help you get ready. Just like any other provider, they have lots of services that enable you to do everything from running existing applications on VMs to doing all kinds of things like bots and mixed reality and all that kind of stuff. The portal, which is pictured here, is a web portal that gives you a console view of everything that you could do through command line. It is your go-to place to start. So when you start working on your skills submission, this is where you'll begin. It is separate from all your other projects, so it should never go down. The Azure Marketplace helps you get more right away with, for example, if you wanted to use a Red Hat Enterprise, you would just click on that to get it started. Or if you wanted to build a SQL database, they already have something built in ready to go. So you don't necessarily have to start from scratch when you get into Azure. Here's a big picture view of the available services. For example, within compute, you have things like the virtual machines, the scale sets, Kubernetes, Service Fabric, batch container instances, and Azure Functions. It has networking, a section that handles everything from the virtual network, any load balancers, application gateways, VPN gateways, DNS, your content delivery network, your DDoS protection, traffic manager, express route, network watcher, firewall, and virtual WAN. It also has 4 main types of storage: blob storage, file, queue, and table. According to Microsoft, they all share several characteristics. They're durable, they're secure, they're scalable, they're managed, and they're accessible. Now, the security side of me will remind you that it is not the service that will make it vulnerable. It will be the misconfiguration of a user that'll make it vulnerable. So it may start as a secure hardened service, but it takes a user to misconfigure it and then make it vulnerable to attacks. In Azure, you're able to create mobile backends for iOS, Android, and any Windows apps. So they can connect to things like SAP, Oracle, SQL Server, SharePoint, and so on. You have a number of databases available to you, from Cosmos to SQL to MySQL, MariaDB, Redis, and even some analytic stuff. There's, of course, a web, from app service to API management to cognitive search. There's also IoT, because they want to stay, remember, they want to stay future. So there are connections for IoT Central. They also handle big data, AI, and DevOps. So to create any Azure accounts, you'll need an Azure subscription. This is the basic structure of how they work. When you're working from your own applications and business needs, you'll need to create an Azure account, and a subscription will be created for you. After you've created that account, you're free to create additional subscriptions. So you could use a single Azure account for your business and separate subscriptions for development, marketing, and sales. After you've created an Azure subscription, then you can create resources within each subscription. So, of course, the Azure account needs to be protected, because it's through that everything else is made. The Azure free account will include some free access for 12 months, credit to spend, and more than 25 products that are always free and won't count against you or your credit. Any questions on the content? Looking at the chats, I see questions about activating an account. We'll handle those later. Cool. Then we'll continue. So we talked about your advantages of going to the cloud, which in all honesty, you really should be familiar with using cloud resources. And that's why we're going to put our focus this course into Azure, your high availability, your scalability, and all that. But let's talk finance, because this is very important. Your cloud service provider, in this case, Microsoft, operates on a consumption-based model, which means that the end user will only pay for the resources that they use. Whatever is used is what you pay. So there are no upfront costs, no need to purchase and manage costly infrastructure that users might not use to the fullest, the ability to pay for additional resources when they are needed, and stop paying when they are no longer needed. There are two different types of expenses that you need to consider. There's the capital expenditure, which is the upfront spending of money on physical infrastructure, and then deducting that upfront expense over time. The upfront cost from capital expenditure has a value that reduces over time. There is also the operational expenditure, spending money on services or products now and being billed for them now. You can deduct this expense in the same year you spend it. There is no upfront costs as you pay for a service or a product as you use it. Cloud services are categorized as operational expenditures, because in comparison, a capital expenditure would be something like buying a physical server whose value will go down over time. This is one of the reasons why it's cheaper to go cloud than having physical. So looking at these three again, we can look at them from the capital and operational expenditures. The first one, the infrastructure as a service, is the most flexible category of cloud services. It gives you complete control over the hardware that runs your application. And instead of buying the hardware, you're essentially renting it. There is no capital expenditure to IaaS. You have no upfront costs. Applications can be made accessible quickly and deprovisioned whenever needed. Management is shared. The user manages and maintains the services they have provisioned, and the cloud provider manages and maintains the cloud infrastructure. Organizations will pay for what they use and operate under the operational expenditure model. No deep technical skills are required to deploy, use, and gain the benefits of the public cloud. Organizations can rely on the skills and expertise of the provider to ensure workloads are secure, safe, and highly available. They're flexible because you have control to configure and manage the hardware running on your application. And you have your other cloud benefits. Platform as a service has the same benefits as infrastructure with some additional. Again, it is a no cap because users don't have any upfront costs. Platform as a service is more agile than infrastructure. Users don't need to configure servers for running applications. It's still consumption-based under what you use. You don't need any deep technical skills. The cloud benefits are that the cloud provider ensures your workloads are secure and highly available, not you. So productivity can be focused on application development since the cloud provider handles all the platform management. Your disadvantage of platform as a service is there could be some limitations that might affect how the application runs. So if you're going platform as a service, be sure the workload meets the needs and know of any limitations that exist. Your software as a service, centrally hosted and managed for you, again, doesn't have any upfront cost, is much more agile. It uses the pay-as-you-go pricing model. No deep technical skills are needed. And it is much more flexible since users can access the same application data from anywhere. The disadvantage becomes the software. Because you're using as-is software, you don't have control of the features. So you always are balancing what will work best for your situation. Any questions on that section? Looking at the chats. Co-location falls as infrastructure as a service. Cameron, I'll answer that question after we go through the content. Right now, any questions on the content? Okay. The last section of the night. Like I said, these sessions won't go until 9:30. Here is, again, the hierarchy of how Azure works. Once again, in order to use it, you need to have an account and subscription. The subscription provides you with authenticated and authorized access to Azure products and services. It allows you to provision resources. It's a logical unit of Azure services that links to an Azure account, which is an identity in the Azure Active Directory or in a directory that Azure AD trusts. An account can have one subscription or multiple with different billing models to which you apply different access management policies. For example, there's the billing boundary that determines how an account will be billed. It can have multiple subscriptions for different types of billing requirements, or access control boundaries. These are set at the subscription level to help you reflect different organizational structures. For example, within a business, you have different departments, which you would apply different policies. You can create additional subscriptions based on things that you want to separate, like environments, organizational structures, or billing, or even subscription limits. If you have multiple subscriptions, you can organize them into invoice sections, which will be important, and your accounting departments will love you. Each invoice section is a line item on an invoice that shows the charges incurred every month. Depending on your needs, you can set up multiple invoices within the same billing account. This diagram shows an overview of how the billing is structured. You can adjust it as necessary for your business needs, which again is super important because you want to make it clear and easy for people like accounting and business offices to be able to handle this, since they won't understand how the cloud works, but they will understand how to get the invoices paid. If your organization has many subscriptions, you'll need to help manage them, their policies, their compliance. You can also build management groups and subscriptions to help you turn everything into an easy to understand hierarchy. This is just one example of creating a hierarchy for governance by using management groups. So you see that human resources has access to the development and test subscription. Marketing only has free trial. IT has a couple more divided up into different regions. You can create hierarchies that apply to a policy or make management groups for multiple subscriptions. A couple of facts that you'll need to keep in mind is 10,000 management groups can be supported in a single directory. A management group tree can support up to 6 levels of depth. This does not include the root level or the subscription level. Each management group and subscription can support only one parent. Each management group may have many children. All subscription and management groups are within a single hierarchy in each directory. So these resources that I speak of, that you can group up, we start with these resource groups. They are the fundamental element of the platform. They can be logical containers for resources deployed. For example, they could be virtual machines, gateway instances, databases. All the resources must be in a resource group, and a resource can only be a member of a single resource group. Your resources can be moved between groups with some services having specific limitations or requirements to move. The groups themselves cannot be nested. Before any resource is provisioned, you'll need a group for it to be placed in. So they'll exist in a logical grouping. So like usage, type, or location. If you delete a resource group, all the resources contained within it are also deleted. So the lifespan determines, if the whole group needs to go, everything within it will go as well. This is great for experiments, that when you test something out, if it doesn't work, you just get rid of the whole group and everything goes away and life is good. You can start over. Resource groups are also You can apply role-based access control permissions. So it's easy to administer and limit access to allow what's needed. The resource manager, which looks a little more complicated, is the deployment and management services. It provides that management layer that you need to create, update, and delete resources within your account. You can do things like control, lock, and tag, and secure and organize any resources after they're deployed. When a user sends a request from any of the Azure tools, API, SDK, the resource manager will receive that request. It handles the authentication and authorization, and then lets the process continue. So your resource manager is your one-stop shop for all this kind of stuff. Again, you can use it to clarify the billing by grouping resources that share the same tag. You can redeploy solutions throughout their development lifecycle, apply RBAC, use things like JSON files to create templates to help you deploy even faster. Azure is deployed worldwide, as you can see. Now, there are some regions that can only do specific things, but for the most part, you are able to deploy. This map is actually as of June 2020. You can deploy your application, your platform, whatever, across multiple places around the world. So that, again, if something happens where it goes down in one area, it won't go completely down everywhere else. Availability zones are physically separate data centers within a region. Each availability zone is made up of one or more data centers equipped with its own independent power, cooling, and networking. So in the earlier map, we had the various regions, and within those regions, there are availability zones. So you can divide out your application, your infrastructure for even more redundancy by using availability zones within regions. And of course, some zones are able to do more than others, but that's just the availability that you have around the world. You could also even make region pairs. Each Azure region is always paired with another within the same geography, such as the US, Europe, or Asia, at least 300 miles away. That way, it allows for replication of resources across geography that helps reduce the likelihood of interruptions because of events like natural disasters, civil unrest, power outages, physical network outages, so on and so forth. So you are able to take advantage of this as well in order to keep your infrastructure up no matter what. Any questions on the content? Okay. We are halfway through. We have 4 sections left. So we should be done within half an hour or so. This section is all about an introduction to their database infrastructure that Azure has. Starting with Cosmos Database, which I've never heard of until I started looking into Azure. It's a globally distributed multi-model database service. You can elastically and independently scale throughput and storage across any number of Azure regions worldwide. They are fast single-digit millisecond data access by using any one of the several APIs. It also has a comprehensive service level agreement for throughput, latency, availability, and consistency guarantees. It definitely feels like Microsoft is trying to make this the next big database. According to them, it is flexible. At the lowest level, Cosmos Database stores data in atom record sequence format. The data is then abstracted and projected as an API, which you specify when you're creating your database. Your choices will include SQL, Mongo Database, Cassandra, Tables, and Gremlin. This level of flexibility means that as you migrate your company's database to Azure Cosmos Database, the developers can stick with the API that they are most comfortable with. SQL, of course, is available. The high-performance, reliable, fully managed, secure database. SQL is a platform as a service database engine. Handles most of database management functions like upgrading, patching, backups, monitoring without the user involvement. According to them, SQL Database provides 99.99% availability. The platform as a service capabilities that are built into SQL Database enable you to focus on the domain-specific database administration and optimization activities that are critical. It has a fully managed service with built-in high availability, backups, and other common maintenance operations. Microsoft will handle all the updates to SQL and operating system code. You don't have to do any of that. You can create the highly available and high performance data storage layer in Azure. It'll have all the advanced querying processes features. You can process things like non-relational structures like graphs, JSON, spatial, XML within it. It is possible to migrate SQL Server databases with minimal downtime using the Azure Database Migration Service. It'll give you a general assessment and provide recommendations to help you guide you through the migration. It will do most of the steps, and you'll provide some of the information necessary in order to make it happen. There's also the SQL Managed Instance. It's a scalable cloud data service that provides the broadest SQL Server database engine compatibility with all the benefits mentioned earlier. So yes, it is a platform as a service, but you won't need to purchase and manage expensive hardware. You won't need to maintain that additional overhead of managing your on-premise infrastructure. It'll have that uptime and service level agreement. It provides several options that don't exist in the SQL database. For example, you could use other languages. and be fine. It has the same process of migration from if you have an on-premise up to the cloud. They have MySQL as well, the relational database with, again, the high percentage availability. You'll get that the high availability with no additional cost, the predictable performance and inclusive pay-as-you-go pricing, the scaling as needed within seconds, the ability to protect sensitive data at rest and in motion, your automatic backups, and your enterprise-grade security and compliance. All those features don't have really much administration and provided at no extra cost. Yay. The same database migration service can handle MySQL as well. Postgres, another relational database, is also manageable in Azure with the same availability, even automatic backups and point-in-time restores. You have two ways of deploying Postgres, either single server or hyperscale. The hyperscale horizontally scales queries across multiple machines by using a process called sharding. The query engine will basically parallel the incoming queries across several servers for faster response against large data sets. The hyperscale option is great for multi-tenant applications, real-time operational analytics, and high-throughput transactional workloads. Along with all these, there are also your big data and analytics, like the Synapse Analytics, formerly called the SQL Database Warehouse, the HD Insight, a fully open source analytics service for enterprises. That one works well with a lot of Apache products like Spark, Hadoop, Kafka, HBase, Storm, and machine learning services. Databricks helps you with data for AI. And Lake Analytics for job services to simplify big data. Any questions on database? Okay. Then we'll move on to compute services. If you've worked with any cloud providers, a lot of this is familiar. Azure uses normal terms like virtual machines to define certain things. You can use those virtual machines just as you would in VMware or VirtualBox. That's exactly that. The virtual machine scale sets is to deploy and manage a set of identical virtual machines. With all VMs configured the same, the VM scale set are designed to support true autoscale. There is no pre-provisioning of virtual machines required. They can handle various workloads. So as demand goes up, you can add more VMs. As demand goes down, you can remove VMs. That process can be made automatic, manual, or both. Of course, as with any modern data center and cloud provider, they have already Kubernetes. They have app service where you can quickly build, deploy, and scale web, mobile, and API apps. And functions, which is definitely unique to Azure, where you're only concerned about the code running your service and not the underlying platform or infrastructure. These are used to perform work in response to an event or REST request, timer, or a message from another Azure service, and when that work can be completed quickly within seconds or less. Your virtual machines could be used when testing and development, when running applications in the cloud, extending your data center to the cloud, or disaster recovery. VMs are an excellent choice when moving from physical to the cloud, because you can create an image of a physical server and host it within the VM with little or no changes. Of course, like any other VM, you'll need to maintain it. Single VMs are great for testing and minor tasks, but Azure allows you to scale them and use them in batches. And we pretty much covered where making scale sets would be ideal when you need to have more than one VM to manage a service or run an application. Azure Batch enables large-scale parallel and high-performance computing batch jobs with the ability to scale tens, hundreds, or thousands of virtual machines. What Batch does is it'll create a pool of VMs for you, install the application and any staging data. It'll run the job with as many tasks as you have, tell you about any failures, requeue the work, and scale down when completed. Containers and Kubernetes are accessible in Azure. Containers are a virtualized environment, much like running multiple virtual machines on a single physical host. You can run multiple containers on a single physical or virtual host. Unlike virtual machines, they don't have an operating system within them. They use whatever the host has. They are lightweight, designed to be created, scaled out, and stopped dynamically. It is possible to create and deploy VMs as needed, but you can also use containers to respond to those changes in demand. The most popular one, being Docker, is completely supported by Azure. You also have Kubernetes. Which is basically an orchestrator, can start, stop, and scale out application instances as needed. Azure has their own container instance and Kubernetes. So you could use either one to deploy as you need. There are also microservices for those tiny processes that don't need a full-on system or don't even need a container, just need something small to run. App services provide compute resources to run specific little items. You could create a plan to determine whether the service will have dedicated or shared hardware and how much memory will be reserved. There's even a free tier to host small, low traffic sites. For example, you could use web apps, API apps, web jobs, and mobile apps. Go back a slide. The web apps can be anything for hosting from ASP.NET, ASP.NET Core, Java, Ruby, Node.js, PHP, or Python. And you can choose to run it in Windows or Linux. Your API apps are the REST-based web APIs by using your choice of language and framework. The web jobs can run a program like a .exe, Java, PHP, Python, Node.js, or even a script like Command, PowerShell, or Bash in the same context as a web app. They can be scheduled to run by a trigger. And of course, mobile apps will be your backend for iOS and Android. Functions, mentioned earlier, use that serverless computing, the abstraction of servers, infrastructure, and OSs. Azure will take care of managing the server infrastructure and allocation or deallocation of resources based on the demand. The infrastructure is just not your responsibility. All scaling and performance will be handled automatically. Like I said, all these functions are scaled on demand automatically. So if you know your demand for this application will be variable, function will be the way to go. If this was a virtual machine, then you would incur the cost when things are idle, but not so much with function. Logic apps are similar to functions. Both are enabled in an event. When functions execute code, logic apps execute workflows that are designed to automate business scenarios and are built from predefined logic blocks. Each of these logic blocks start with a trigger, which fires when a specific event happens or when a newly available data meets specific criteria. Can be like basic scheduling. It can be, whatever will trigger something like a new entry into data. There are over 200 different connectors and processing blocks to interact with for many different services. And they work with a lot of the popular enterprise apps already. If your specific situation needs something custom, there is the availability for that as well. So your basically function versus logic apps, the state in a function would be stateless, a logic app would be stateful. For functions in development, they are code first, whereas logic apps are designer first. Your connectivity for functions would have about a dozen built-in binding types. Logics have large collection of connectors. Your functions have a Azure function, and you'll need to write code for a specific activity function, whereas a logic app, you'll collect data for ready-made actions. Functions can run locally or in the cloud, whereas logic apps will only run in the cloud. In addition to all the other things that we've mentioned so far, you also have Windows virtual desktops to provide users with a cloud-hosted version of Windows from any location. Now, it'll work with apps that you can use to access remote desktop like RDP. It can provide the user experience that a lot of users know using like the Windows Virtual Desktop HTML5 web client. You can run VMs through that and have users sign in as usual. They'll have enhanced security using the Azure Active Directory instead of a local. Users' sessions are isolated in both single and multi-session environments. They also have reverse connect technology, which is supposed to be more secure than RDP because they don't open any inbound ports to the session host VM. Some key features are simplified management, performance management, and multi-session Windows 10 deployment. You can bring your own licenses to Azure if you bought them, like Windows or Microsoft 365 licenses. Or if you have the remote desktop client service access license, you can use those. Or you could buy a 1-year or 3-year Azure Reserve virtual machine instance for pay-as-you-go. Checking in to see if there are any questions on the content. Okay. 2 more sections left. This will be the storage and the networking. Oh, that's actually a good question. Why does Google Cloud include Windows Server license, but Azure licenses the OS and the VM separately? I don't actually know the answer. I am more than sure that it is part of Microsoft's how they get their money. I don't know why Google doesn't. Well, Google does include the license. They do, but it's not upfront. They, if you go on Google Cloud and you make a Windows VM, they are always more expensive than the Linuxes. So I think what Google is doing is taking the price tag for the license and spreading it out into your usage. Not sure why Azure won't do the same. But interesting view there. All right. In order to begin using your Azure storage, of course, you'll need to have your account to create those data objects. You can create a storage account by using the portal, PowerShell, or the CLI. Your storage account will contain all your storage data objects from blobs, files, and disks. A storage account provides unique namespace for the storage data that's accessible from anywhere in the world over HTTP or HTTPS. Data in this account is secure, highly available, durable, and massively scalable. Now, I question the secure if your data is available over HTTP, but what do I know? Disk storage provides your virtual disks for virtual machines. They can be accessed as needed, similar to on-prem scenarios. They have different sizes and performance levels, from solid state to your regular spinning disks with various performance tiers. You can use standard SSD and HDD and hard drives for less critical workloads, or premiums for mission critical production applications, ultra disks for data intensive workloads, top tier database transaction workloads. They have, the way that they use storage is just like all the other providers, where you don't actually know when drives die. The physical drive could die, but they have replications so that your data is never affected. Blob storage is an object storage solution for the cloud. It can store a massive amount of data like text or binary. It's unstructured, meaning there's no restrictions on the kind of data it can hold. It can manage thousands of simultaneous uploads, massive amounts of video data, and constantly growing log files, and can be reached from anywhere. They're not limited to common file formats. They could contain gigabytes of binary data streamed from, for example, a scientific instrument, or an encrypted message from another application, or data in a custom format for an application you're developing. One advantage of blob storage over disk is it doesn't require developers to think about or manage the disk. Data is just uploaded as blob, and Azure will take care of your physical need. Blob is great when using things like serving images or documents directly to a browser, storing files for distributed access, streaming video and audio, storing data for backup and restore, disaster recovery, archiving, storing data for analysis by an on-premise or Azure hosted service, storing up to 8 terabytes of data for virtual machines. Azure Files gives you the fully managed file share in the cloud, accessible through SMB and the network file system protocols. They can be mounted concurrently by cloud or on-premise deployments of Windows, Linux, or Mac. Applications running in Azure virtual machines or cloud services can mount a file storage to access file data just like they would if it was a typical SMB share. Any number of virtual machines or roles can mount and access a file storage share simultaneously. They can be used for on-premise application use file share, store configuration files across multiple VMs. When data, you can write data to a file share and process or analyze the data later. Files that are being shared across, for example, 2 geographical locations will be encrypted at rest and in transit. You can access files from a browser using the URL. You can also use the shared access signature token to get access to private information. So here's an example of a service shared access signature URI, showing the storage resource URI and the token. Data stored in the cloud can grow at an exponential pace. So we need to keep in mind, again, the finances of managing the cost to expanding storage needs. You have different tiers to handle your blob storage. For example, hot access tier, optimized for storage data that is accessed frequently. For example, images on your website. Cool access, optimized for data that is infrequently accessed and stored for at least 30 days, like an invoice. Archive access, appropriate for data that is rarely accessed and stored for at least 180 days, with flexible latency requirements. So when applying different access to tiers, know that only hot and cool access tiers can be set at the account level. Archive tier isn't available at the account level. Hot, cool, and archive tiers can be set at the blob level during upload or after. Data in the cool access tier can tolerate slightly lower availability, but still requires high durability, retrieval latency, and throughput characteristics similar to hot data. Cool data has a slightly lower availability SLA and higher access costs compared to hot data. Archive storage stores data offline and offers the lowest storage costs, but also the highest cost to rehydrate and access that data. So when you're setting this, you have to think about how often are we going to access this data? Is it going to be, do we need it quickly? Do we need it all the time? Do we need it sometime, or do we access this really, something stored for a long time? That will determine what SLA will be attached to it, will determine how fast you'll get it back or forward as needed. Any questions before we enter the last section for this week? Again, questions on the content. Okay. So the last section will be networking. At this point, you should already be familiar with networking concepts, with how devices talk to one another, from LAN to WAN, how IP addresses function, all that kind of stuff, how VPNs work. All of that is available through Azure and available through most cloud providers. You can use things like route tables, the border gateway protocol, VPNs, isolating networks, all that kind of stuff in Azure, just like you can do with most providers. You can create and configure virtual networks through the portal, PowerShell, local computer, or Cloud Shell. You'll have a number of options to configure, like multiple subnets, distributed denial of service protection, service endpoints. As you go through the process, you'll configure basic things like the network name. Doesn't have to be globally unique. The addressing space. So again, having that knowledge of CIDR is important. The subscription that you'll apply, the resource group that this will exist in, the location, the subnet, the DDoS protection, and endpoint, along with adding things like the network security group, any route tables as needed. After you've created those virtual networks, you can change settings later in the virtual network pane, or use PowerShell or Cloud Shell to make changes. You'll also have access to further things like address spacing, connected devices, subnets, and peerings, along with being able to monitor and troubleshoot virtual networks. Again, having that networking knowledge comes into play when working on the cloud. You can deploy VPN gateways. They're deployed within the virtual network instances and give you things like connecting on-prem data centers to virtual networks through site to site, connecting individual devices to virtual networks through point to point or point to site, and connecting virtual networks to other virtual networks in network to network. As with any VPN, all traffic is encrypted because otherwise it wouldn't be a VPN. They'll use the Internet Key Exchange in either version 1 or 2 and IPsec. You can deploy policy-based VPNs using IKE version 1 or static routing. You can use route-based VPNs as well. Those will use IKE version 2. Those can be used for connecting virtual networks or point to sites or multi-sites. Your gateway sizes will be important. They go from a maximum of 10 to a maximum of 30. Their aggregate throughput can be from 100 megabits to 1.25 gigabits. Deploying them will require some Azure and on-premise resources. For example, the virtual network, the gateway subnet, which is a /27. You won't be able to use that subnet for anything else. The public IP address, the local network gateway, the virtual network gateway, and the connection, which you can create multiple connections to the VPN. On premises, you'll need the VPN device that supports the policy of router-based VPN gateway, and of course, a public-facing IPv4 address in order to establish the connection between the cloud and local. You can create fault-tolerant configurations. For example, an active standby. You can deploy 2 instances in an active standby configuration. In case one goes down, the other one will jump right in a couple seconds. They're typically restored within a few seconds or planned maintenance within 90 seconds. There's also the active-active, using BGP to deploy VPN gateways in this configuration, extending high availability and being able to deploy separate tunnels and additional VPN devices. There's also express route failover and zone redundant gateways. Express route failover is just like secure failover. It has resiliency built in, even though they won't be immune to physical problems like unplugging the cable or power outage, but they definitely add that extra protection and extra security in the network. And there's also the zone redundant, so you can bring further resiliency, scalability, and high availability to virtual network gateways by spreading out within a region. So ExpressRoute lets you extend your on-premise network into Azure over a private connection with a connectivity provider. So it can be any to any network, any VPN network, or a point-to-point Ethernet network. It allows ExpressRoute connections to offer more reliability, faster speed, consistent latency, higher security than your typical connection. It does layer 3 connectivity, connects to Microsoft's cloud service across all regions. Global connectivity is a premium add-on. So you can connect to any regions in a geopolitical region, but you can do global as well with a premium add-on. You can do dynamic routing with your network in Microsoft through BGP. You'll have built-in redundancy. You'll have an SLA and quality of service for Skype. The connectivity models that exist are the Cloud Exchange colocation, which offer your layer 2 and layer 3 connections between your infrastructure, your point-to-point between your premise site and Azure, and any-to-any, integrating like wide area network to your Azure data center. The idea being with ExpressRoute, your data doesn't travel over the public internet, so it's not exposed to potential risks. You can do things like DNS query, certificate revocation, content delivery, and keep your data secured through these private connections. Any questions? So as a reminder of the work to be done each week, let me switch to this now. Each of these sections has a knowledge check. Some even have exercise activities. These are the things you'll need to complete that'll help you get the XP you need. So when you complete going through these sections and completing the knowledge checks, that will turn green. Read through, complete your knowledge check, that'll turn green. Read through, do the exercise and the knowledge check, that'll turn green. And you submit that as proof that you completed the part 1 submission. Then you'll do the same for part 2. And again, if you feel like you want to just jump forward and do 2 more, 3 more, whatever your time allows, there is no penalty to going ahead. If you finish all this early, because a lot of it, as you see, is very fundamental and it's not really going in depth, you are welcome to finish everything and then go ahead and start working on your skill submission. That is perfectly fine. On the Cabrillo folks, you have the dates when everything is due. So again, if you go ahead, that is perfectly fine. But I've scheduled this out so that you should be able to complete each module in 4 weeks' time, with the last one being your choice. So In the next 12 weeks, or in the next 3 weeks, we'll finish AZ 900. Then we'll do the DP 900, which will be data fundamentals. Then we'll do Azure Administrator, and then you'll have your choice of which one of the many certs that they have you accomplish. You complete those, or you complete the one you want to do. You'll do your skill submission, and that'll complete the whole course. Discord is highly required because, again, you'll need to be collaborating with one another. You are able to work together to help go through the content or prepare your infrastructure and whatnot to prepare, do your video. Again, I expect collaboration in this course. So if you are not collaborating on Discord, StatBot will see that you are not busy, and therefore you'll get a low grade. Discord discussions are part of your grade. And like I said, last semester, some students didn't realize that, and when the grades came due, their overall grade dropped a letter because Discord has that many points. All the recordings will be available on YouTube. I already am making a playlist where you can watch this later. Now, I know there's a question about getting access into Discord that'll handle when we stop the recording, but are there any other questions about the class in general, how this is going to work for the next 12 weeks, or any other content that we just covered? Awesome. If you do come up with any questions, please ask away on Discord. So I will now stop the share and stop.